Hey guys, welcome to All Tech All Day, where I try to keep you updated on the world of tech, the state of tech, and everything happening in the tech world. This is going to be something new I'm trying. I'm going to be trying to do longer format videos just for this YouTube channel in order to try to differentiate some of my channels and reach out to different audiences. Longer format videos will go here on the YouTube channel. Individual posts will go on the Instagram, and my daily 3-minute videos will go on all platforms, with YouTube having a shorter 1 minute kind of clipped version of it, since you can only upload shorts of 1 minute or less. Now, today I want to discuss something more in depth of a video I did earlier this week, which is the 14th generation of Intel processors. I went over the core components, but this video is going to be me breaking down each one individually and kind of explaining why and how this helps and improves the actual performance of the processor, and why this is technically a new generation of Intel processing, and how it's a huge leap from the last wave of processors we've gotten recently. So, if you may have noticed, between the 9th and 10th gen of Intel processing, things got really intense. There was a huge performance bump, there was a huge performance change, and you're going to see this now between the 13th and the 14th gen. It's going to happen again. There's going to be a lot of differences, a lot of changes, and a lot of improvements in the way that they do things. So, let's discuss from the beginning. Intel has announced their 14th generation processors. They promised them before the end of this year, and they are going to make good on their promise. December 14th, 2023 is the date that they have set to release these processors. This will be codenamed Meteor Lake, and it's going to make a huge splash. I'm going to tell you this much. It is built on a 7 nanometer architecture still, which is what the last generation of processors was built on. However, this is called the Intel 4 architecture. So it is still the same size of chip. However, it is going to be arranged differently, and the processes are going to be organized differently in the way that it does that. The way that it does this is it has a hybrid tile architecture. It is a three-dimensional hybrid tile architecture is what they describe it as. That is because they have 4 different tiles on the actual die that are each dedicated to different types of processing. There is going to be a graphics tile dedicated to just the GPU processing. There's going to be an SoC tile, or a system on a chip tile, specifically to run a neural processing unit and AI level and machine level workloads, or machine learning level workloads. And this is going to be done using a new type of E-core, which are efficiency cores called low power efficiency cores. The point of these is to sit on that chip and work in the background on this new SoC tile. The next one will have an I/O tile specifically for PCIe ordering, including your USB controllers, your audio input output controllers, and the actual PCIe buses where you put your graphics cards and such. And the last one is going to be your compute tile. That's going to be the largest and most important tile that contains your performance and efficiency tiles that are dedicated to actually doing things on the computer. Now, with all of this, we're going to get about a 20% overall better power efficiency for these chips, and we're also going to get about a 20% power reduction using the AI and machine learning technologies on this SoC tile using the LPE cores, which are the low power E cores. This new neural processing unit will accelerate the onboard AI, and this is the first time that we're getting this on an Intel chip, and that's why they have to use this new technology. So, on this neural processing unit, we're going to get what are called low power E cores, or LPE cores is what they're referring them to. These are very low power, very low workload cores that are running essentially an entire program on a quarter of this chip. And it is running an AI generation unit as well as some machine learning in order to handle smaller tasks in the background. So these smaller, more repetitive tasks that happen in the background on a Windows machine or whatever machine this is a part of will now be dedicated to this specific SoC, or system on a chip, and it will handle this processing. It will not affect the overall performance of your processor. It will be able to handle smaller workloads in order to offload these workloads from the larger P and E cores on the dedicated compute tile. The point of this is to allow you to do more with your machine and allow you to do more multitasking and more intense computing on your machine just using your processor. Now, that is going to be the SoC tile kind of in a nutshell. The next one we're going to talk about is going to be the graphics tile. Now, Intel released an Intel Arc graphics card series, and you may have noticed it wasn't that great, but it allowed them to improve their overall graphics processing and allowed them to create a technology that they are now implementing onto the chip itself. So the same Intel Arc graphics power is now being integrated into the processor. Although it will be clocked down a little bit, it will be on a dedicated GPU chip on their processors. You will be able to run AAA games at 1080p from anywhere from 30 to 60 FPS, as they have claimed. We still have yet to see evidence for this. Once the chips come out, we will get more benchmarks and information, and that will be without a dedicated GPU or graphics processing unit in your computer. You will have support for real-time ray tracing, which is the first time this has been available on any Intel chip or AMD chip by itself. You can run up to 8K resolution at up to 60 hertz. So that would be 4K at 120 hertz, 8K at 60 hertz. You can run 1440p at 240 hertz. That's going to be kind of an idea to like explain how great that is. Of course, Apple Silicon can do this already, but this is crazy that just the individual Intel chips are now going to be able to support this in addition to whatever is actually included in the power of the machine. They are also adding HDMI and DisplayPort 2.1 ports, or port support, which is something that was already established as a standard, but has not been widely adopted by NVIDIA as a graphics support. But AMD has adopted this in their RX 7000 cards. So that's going to cover the graphics tile. So that's going to be 2 of your 4 tiles here. The next tile that we're going to talk about is going to be the I/O tiles. Now, the I/O tiles are essentially just controls all of your ports. So I/O stands for input output, in case you didn't know. And these ports are going to be your USB ports, your headphone jack, SD card readers, PCIe slots on the board, M.2 slots on the board, your SATA ports. All of that is getting a great improvement. We're going to have better cache, we're going to have better speed, better efficiency. We have support for PCIe Gen 5 speeds, which includes NVMe Gen 5 drives, which is something that is still like being developed, still kind of a futuristic technology, but they are going to have support for it now. That way, when it actually becomes mainstream and widely adopted, then it will already have support for it. AMD may not already have support for it by the time it's actually established. But this gives them a lot of time to stabilize this technology and a lot of time to think about what the issues are and work out the actual problems and figure out how they're going to fix and stabilize this technology. So the I/O tile is just going to overall be a little bit faster. It's going to support brand new technologies, and it's going to support technologies that aren't even mainstream yet, that aren't something that everyone has. Things that people who have thousands of dollars have, but not the modern common person. The last thing we're going to talk about is the compute tile. The compute tile is the 4th tile. It handles most of your processing. It handles most of the actual workloads of the computer. There are 2 different things on this tile, and that's going to be your P and your E cores. Your P cores are your performance cores, and your E cores are your efficiency cores. Your performance cores are what are going to do the higher clocks and are going to handle your more intense workloads. The things like the gaming on your actual PC, or if you're running intense processing or you're running 3D benchmarks and such, that's going to be dedicated to your P cores. Your E cores are going to be separated from that and handle smaller, lower workloads, such as processing a regular web browser or handling lower quality tasks that aren't already offloaded to your NPU. So essentially, how this works together is you now have a 3D system for your processing. You have your LPE cores, you have your E cores, and then you have your P cores. Anything that is very small in the background, workloads that happen over and over and over again, are going to be in your LPE cores. Next, you have your E cores, which are going to handle lower power workloads in order to not overwork your processor and overwork your performance cores. So you're going to be doing web browsing and basic video watching on these E cores. Next up, you're going to have your P cores. These are your high performance cores. These are going to be the ones that get clocked up and overclocked if you have an overclockable processor. And these are going to be the cores that handle most of your games. So if you're trying to run these new AAA games on your graphics unit, you're going to be taking advantage of those P cores and their overall power and performance. This is also going to allow you to do Photoshop and other kind of video editing softwares on your laptop, and it's going to be able to handle it because Photoshop is going to be dedicated to that P core, while your E cores are handling the background noise that's happening underneath it. So that is why this is now a 4-tile 3D architecture of processing, because you have so many different lanes and so many different steps that they have very carefully crafted and established for you to do. So the next step is that they added to kind of add more to this new architecture, this new design, is we have Wi-Fi 7 support. Wi-Fi 7 is a brand new standard. Routers for Wi-Fi 7 are like $1,000 right now. So it is not something that everyone has right now. And this again goes with Intel's drive in this chip to establish new technologies right now in order to support them. So when they come to mainstream later, their older processors are still able to support the newer technology. And they can still say, hey, my 14th generation processor from 6 years ago still has support for Wi-Fi 7 and PCIe Gen 5 and M.2 Gen 5 chips. They want to make it future-proof. That's what they're trying to do. So they're establishing Wi-Fi 7 support in their processors. It challenges current wired connection speeds. They're very similar. They're very fast. It's got lower latency, up to 60% compared to Wi-Fi 6, and I believe it's up to 40% compared to Wi-Fi 6E. It supports the new 6 gigahertz band, which will create a tri-band Wi-Fi, and you have 5 gigabit per second speeds, which is incredibly fast for Wi-Fi, with 256-bit encryption, which is really great because it allows for these transfers. If you're sitting in a coffee shop and you're using the Wi-Fi 6 or Wi-Fi 7, the more bits there are, the less likely it is someone's going to be able to decipher the packets going to and from your laptop and that public Wi-Fi network. It's going to make it harder for people to access your information. It's going to make it harder for them to get in and find your passwords and anything like that. Also, they're introducing Bluetooth LE. Bluetooth LE is a more power efficient, a lower latency, and a much better solution to Bluetooth. It reduces the power consumption on Bluetooth chips. It allows you to share audios with others and a lot better audio overall because you have lower bit rates and lower bandwidth requirements. There is a bit of a cost at Bluetooth LE. Sometimes things get compressed a little bit too much and it doesn't always come through perfectly, but Bluetooth LE is a lot better than the standards we've had for Bluetooth previously. The last thing that we're going to discuss is going to be removing the branding that they've had for years and years. For 13, 14 years now, Intel has had the Core i variants. So everything is a Core i3 dash whatever the subclass is, right? So Core i5 4700K or Core i7 9700KF or whatever. That is going away. We are now getting a new naming scheme where you will get Core 3579, so no I, and Core Ultra variants for 5, 7, and 9. So it will now be named such as Core Ultra i5, and then however they decide to name the second half of it. We still have yet to know what they're going to do with the subclass naming schemes, if they're going to keep their HKU naming scheme that they use in order to establish high efficiency or overclockable or lacking graphics with the F subclass. We don't know quite yet. They may have announced it, but as far as I've seen, they haven't really established what they're going to do with the letters that happen at the end of the names. But it will now be considered Core I, or no longer I'm sorry, Core 3, whatever the class is, Core Ultra 5, whatever the subclass is. And this is going to change the way they name things, and it's going to have to change the way we talk about and discuss the actual processors, because now we have to establish that there is now Core 3 and Core i3 and Core M3. These are all different types of Core 3 processors, but they're all within different realms, within different generations. And the point of this branding is to establish that this is a new step forward for them. This is a new improvement. This is a new generation of Intel. This is future-proofing at its finest. And I gotta say, I'm very impressed with what Intel's doing here. It may not be the best gaming chip. It may not be the best, processor for you. But in my opinion, this is going to be the best processor for the common person, for someone who just needs to pick up a laptop and use it and make sure you can use it for years to come. So that's all I have to say about that. Thanks for sticking around for the video. Let me know if you have any other things that I can improve on these videos, anything that you think you want me to discuss about, or anything like that. And I will take it all into consideration for both my short-term videos and for my long videos. So have a great day. Thanks for watching.